Hi, my name is James McCarthy-Holland and I'm the Head Department for Physics, IT and Computer Science, but today I want to talk to you about computer science. One of the first things that people ask me about is what will I study on the course, and we look at all the core elements of computer systems, usually from a modelling point of view. So we'll look at computer architecture, how the processor works, how the system works more generally. We'll also look at how hardware works more generally. Again, not really from a taking computer apart point of view, but from how different models of it actually work and can be applied in all systems. We'll also look at data representation, how images, sound, text, numbers are all formed inside a computer and held in memory. Probably the biggest topic is, of course, programming and system development. That is going to form roughly half of the course. We obviously will teach you from a theoretical point of view, but clearly the practical is the bit the most enjoyable. And every single week you'll have at least one programming lesson, where in the high-level languages we'll look at Python, and we'll look at it from both preparing you for the Paper 1 exam, which is a programming exam, but also preparing you for your coursework in the second year. We'll also learn some low-level languages, particularly assembly, and you'll actually get to do some assembly programming, and that is something that is assessed. We'll also look at SQL, another assessed language, so that you become quite proficient in querying databases and creating database systems. Alongside that, there's something that you won't have done before, even if you did GCSE computer science, in terms of functional languages. And we'll learn Haskell, which is a completely different way of working and something that is going to be a real eye-opener to you, but it's something that's a real look ahead if you choose to do computer science at degree level. Obviously other topics like networking, ethics and more general problem solving are included.
Hello, my name's Tashfeen and I'm studying computer science. I wanted to study computer science because I knew I wanted to go into engineering. When I looked at the course content, I found it quite interesting and it kind of stood out to me because you get to learn about how computers work, so how they store data and how they follow instructions and how they use logical operations to solve problems, which I found quite interesting because the idea of knowing of what's going on behind the screen and not just the technology is really impactful and useful. And although I didn't take computer science at GCSE, I found that the problem-solving aspect of it was very useful, especially alongside maths and other problem-solving based subjects as well.
My name's Scarlett. I study computer science, history and drama. The reason I've chose to study computer science is I took it at GCSE and I wanted to learn to code a bit better at A-level, and I think that the world is moving towards a more tech place, so I think it's important for most people to take, even if you're not going into that field.
Hi, my name is George. I'm an upper sixth student at Godalming College and I've studied computer science, business and maths. I chose to study computer science because it was a continuation on from my GCSE computer science course, and I've always been quite interested in how computers work and how those systems work. So it's just quite logical for me to move on to that. Okay,
in terms of assessment, 80% of the course is assessed through exam. One is a programming exam on a computer. We're given a scenario at the start of the year, and we'll learn that scenario, we'll practice it, but ultimately you'll go into an exam where you have that scenario up on the screen and the exam will actually ask you to do certain things in the programming language live. It is a challenging exam, but one that you're very, very well prepared for. The other exam is a theory exam, fairly traditional. You're asked questions, some calculations, some explain, some problem solving, as well as some scenarios in that are programming scenarios, but are written ones, particularly in SQL, and in assembly. The other 20% of the course is made up of the NEA, the coursework. This is complete free choice. We're happy for you to do it in any language you like, although most students do use Python. And we're also happy for you to use any topic you want, as long as we can understand how you're going to develop it into a complete system that you can analyse, design, create and evaluate, and crucially, will fit the mark scheme. It has to be something achievable within the time, but as long as we're happy with that and it's something that you're passionate about, we're happy for you to do it.
The best part of the course for me was the integration of the theory and practical side of computer science. So learning the internal structure of a computer, as well as learning of some coding skills and practices. The highlight for me was this year in year 13, where we had to do coursework on creating a project to create a program that can create a game or do a certain function for a particular end user. So what I've made was a projectile motion simulator to help maths and physics students visualize and understand how the phenomena of projectile, how it works. And also, because I've enjoyed computer science so much, I decided to undergo an EPQ on cybersecurity, which is one of the fastest growing sectors in the world today.
The thing I enjoy most about the course is the ethical debates, especially around AI and data protection, and I enjoy learning about the hardware and software that can be applied like every day.
Probably my favourite bit around the course is the programming, because I prefer the hands-on more than the theory, but the theory is still quite interesting, especially with how the different devices work inside the computers.
So alongside the main course, we have a variety of extracurricular activities. Our Plus Explore in robotics is very popular. We also work alongside the physics department to give you access to electronics, if that's something you're interested in, particularly focusing on radio. We run the BEBRAS problem solving challenge that you may have done at school, but we obviously do the next level. We're also very fortunate to have a variety of industrial links with people coming in and doing talks, both from local companies that provide IT solutions, but also from cybersecurity companies and companies that are in the games development industry.
The teachers are 100% supportive. Like I said, when I started to take computer science, I didn't know any coding skills or anything like that. So we had to be assigned into some tutorials and some workshops and clinics to help us understand the coding skills. And because of that, I was able to pick up on it quite quickly without feeling that I was left behind with the rest of the set. So I felt like they were very approachable in that respect.
The teachers are lovely. There are lunchtime sessions on Thursday, Friday, and if you ask them, they're very happy to help you one-on-one in lessons and outside of lessons. They're genuinely very lovely people.
The teachers are all very knowledgeable, they know everything to do, they're all very nice. It's very open to go to them if you need help with anything, and the support's always there. There's loads of things online, loads of past papers, questions, everything like that you really need.
Okay, where will computer science take you? Most of our students do go into either higher education to study computer science or a related course, or a degree apprenticeship, again, usually in IT or computer science. We have a variety of students taking computer science courses that are very, very pure, maybe at Cambridge, looking at the very mathematical areas of computer science, all the way through to ones that are very, very practical and are mainly systems development, programming development, or even degree apprenticeships looking at embedded systems, say in the automotive industry. Alongside that, there's a significant number of students that will look at finance, mathematical related courses, or of course engineering. People often talk about what you need to be able to do computer science. Firstly, you definitely do not need to have studied computer science at GCSE to study with us. We're happy to take all of our topics from the ground up. We very much overlap with the GCSE, and then we take you on to being very, very, very well prepared for a degree course. The jump is not really from GCSE to computer science, it's more from the first year to the second year as the course really accelerates in depth of content. Do you need to take maths alongside it? Absolutely not. At degree, roughly half the courses will require A-level maths, half do not. However, if you do take A-level maths, you will find certain parts of the course more accessible.
So once I finish my studies at Godalming College, I'm planning to take a course of general engineering at the University of Warwick, and also plan to take some computer science modules alongside that as well.
After I'm finished Godalming, I plan to go to university for archaeology.
After I finish my A-levels this year, I'm moving on to going to university at Down in Exeter, hopefully, and I'm doing either data science or business analytics, which is another, again, logical step from computer science, going into that analytical data science area.
If everything I've said appeals to you and you think you want to study computer science, we look forward to seeing you in September.